In this example, we're told a particle moves along the curve defined by the vector equation, and we're given the equation. We're asked to find its velocity v. So, because we have a position vector, the velocity v will be the derivative of that, and the acceleration vector, which will be the derivative of velocity. So I've written down the position vector that we're given. We're seeing there is an I component, and I have not written the j. My apologies. So, derivative of 20t is 20. The derivative of 15t minus 5t squared is 15 minus 10t. So my velocity is 20 times unit vector I plus 15 minus 10t times unit vector j. Differentiate that with respect to t to give my acceleration. Well, 20 is a constant, so deriving that it goes. So there is no I component. Derivative of 15 is 0, so it is gone. Derivative of minus 10t is minus 10 in the j direction. There is my acceleration. The second part of the question says, find the magnitude and direction of the velocity and acceleration when t is equal to 2. So, I've substituted t into velocity and acceleration. Substituting 2 into the velocity formula gives me 20i, 15 minus 10 times 2. 10 times 2 is 20. 15 minus 20 is negative 5. So that gives me my velocity when t equals 2. If I look at my acceleration vector though, there is no t in there. It is just constant, so I have just written it as minus 10j because there is no t to substitute the value of 2 into. Now, it asks me to find the magnitude and direction of the velocity and the acceleration. So I'm going to consider velocity first. The magnitude of the velocity would equal the square root of 20 squared, which is 400, plus negative 5 squared, which is 25. 400 plus 25 is 425. Simplifying the surds gives me 5 root 17. Now, that gives me the magnitude. So what I want to do now is find the direction. So if I'm looking at my direction, what I've done is I've drawn a triangle. And the triangle has my I component, the 20, going across, and my j component going down. Velocity is the line joining the two endpoints of those vectors joined end to end. So what I have is a right-angled triangle. So theta is equal to the inverse tan of 5 over 20, which is 1/4, the inverse tan of 1/4. I can now summarize that as follows. When t equals 2, the particle is moving at 5 root 17 velocity units in a direction of inverse tan 1/4 downwards. Downwards we saw it had a negative in front of the 5j. Now I'm going to consider acceleration. So the magnitude of the acceleration is really easy. The magnitude of minus 10 is 10. we know it is moving down and is constant for all values of t.